Hi, I'm Vincent Spiegel. I'm Forsk Head of Sales. I'm very grateful and very thankful to Ericsson for inviting us here today to present our contribution to the EIAP initiative. So Forsk joined the EIAP initiative a few weeks ago. So what I can show you today is mostly a teaser of what can be done thanks to this new architecture. As a matter of introduction, Forsk is a software developer specialized in radio planning and optimization software. We are around for 30 years in this business, and we have two main product lines. One is Naos, one is Atoll, and Atoll is a pretty well-known planning tool because it's used by many operators worldwide. It's a tool which consists in a main platform on which you can run predictions, but also incorporate real-life data to enhance the results of the predictions. And together with Atoll, we have another product line called Naos, which is basically a cloud-native automation platform that provides services for building workflows of radio planning and optimization processes. If we look at what these two products do, what they are meant to is to build a digital twin using geographical data, network data such as sites, cells, antennas, and so on, and also traffic data. With this sort of data, you can build a digital twin of the network and predict how it will behave in certain circumstances. We have quite a strong market share. Many operators use our product to design their networks. And today, there are more than 80% of the North American 5G networks and about 70% of the European networks have been designed using our products. We have also a good footprint in the other areas. If we focus on what automation means to us, initially we were really a provider of interactive desktop tools, but now we stepped into the world of automation with Naos. Naos is an API-based framework allowing the operators to define and develop their own workflows of planning and optimization processes. It's available in a web environment. It uses a cloud-native architecture, so you can deploy it using Docker containers. It's orchestrated by Kubernetes. So we are already in the cloud-native world with this product. Of course, it remains compatible with the well-known Atoll planning tool. When we implement automation, we see significant gains in terms of efficiency and in terms of OpEx at our customers. Here we have some examples of use cases that we have implemented with process automation, like the typical automated coverage map prediction, which we often deliver to our customers. Site provisioning, site decommissioning, parameter optimization. We've seen efficiency gains of a factor of 6 or 12 in terms of time of completion once we have implemented an automated solution in comparison to the old style, I would say, planning tools. So for us, after process automation, the natural step forward is to go into RAN automation. And this is where the cooperation with EIAP, with Ericsson and EIAP, becomes interesting. So what we have with Naos is a platform that provides workflow engineering processes automation. It models a digital twin of the network with antennas, site cells, geodata, everything. It includes AI-powered RAN planning and optimization algorithms. It's based on a cloud-native open API architecture on which we can easily dovetail our apps. Together with the SMO rig architecture as offered by Ericsson, we can not only unlock intelligent RAN automation use cases such as automated run design in engineering, but we can go now even further and offer near real-time analytics and optimization. So basically the things that we used to optimize and used to the optimization that we use to recommend using our products can now be pushed in the network and be implemented in near real time. At the end, we will manage to have a closed loop end-to-end run to automation with this solution. When we talk about run automation, let's illustrate how we see the architecture of EIAP with our products. So we have Naos, which is a platform which is based on microservices. So it's broken down in several pieces of services that can be used in this environment, and we can build rApps from this platform. And these rApps will allow us to pull all the information, all the recommendation that we can find out with Naos in the network and act in a sort of closed loop manner. When we talk about run automation, of course, AI is a topic that pops up quite naturally. So we have this platform which is meant to manage a huge amount of data and huge amount of calculations. So it's a perfect platform for training an AI, because we can handle the millions of calculations that we make on a pixel per pixel base when we make prediction studies or optimization runs. So we can use this calculation, train an AI using deep learning techniques, and out of it, what we will have is a considerable acceleration of all the processes that we manage with this platform. So we will have an accelerated propagation model or prediction calculation, a near real-time coverage predictions, which is very useful when we talk about self-healing use cases. And the consequence is that all the other features of the platform are also speed up thanks to the AI. With this, we intend to implement near real-time use cases, and we have identified use cases where all know-how and all value added is key. All value added is really to be able to accurately predict what is the coverage of a network, and this feature, being able to predict the coverage, has an impact on several crucial use cases. So we can cite PCI planning, neighbor relation planning, run resources optimization, and many other use cases on which we are working today. And we see that thanks to the SMO RIC architecture, we can now also really leverage the impact of the coverage prediction in the optimization, which is something really new on the market. So that's what I wanted to say today. It's a sort of teaser. I hope in a few months to be able to show you more rApps. And well, as a conclusion, I would like to thank Ericsson for the support and the amazing documentation and the simple onboarding that we had for the EIAP project, and hope to see you soon again. Thank you.